So here we have another question. It's going to be very similar in a lot of ways to the question we did before. This question, though, if it showed up, would be on a calculator part of your exam. So again, I go back to my grade 10 math. I'd see that I have some like terms there. If I wanted to get cos by itself, I could add 4 to both sides. That's going to give me -2. Subtract cos on both sides. It's going to give me -2 equals 3 cos x. Divide both sides by 3, and I get cos x by itself. Cos x is equal to -2/3. Why is this a calculator question? Is 2/3 on your unit circle? No. So we have to take out our calculator. We notice that our domain is in radians. So we make sure we hit our mode button and that our calculator is also in radians. And the first thing we need to find is our reference angle. Remember, we always find a reference angle because a reference angle is based on the actual triangle. We always use positive values. So then even though cos of x is equal to -2/3, when finding our reference angle, we go cos inverse of +2/3, and we find out that our reference angle is 0.841. The fact that cos is negative is telling us which quadrants x could be in. X could be in quadrant 2, because cos is negative in quadrant 2. Again, here's our reference angle, and we would know that the adjacent side over the hypotenuse is 2/3 in this triangle. And that's part of the reason why we use the positive values when solving for that angle, is because we're going back to grade 10 trig of SOHCAHTOA. You have a triangle, it's a right angle triangle. How do you find that angle? You would do cos inverse of 2/3. You can't draw a triangle with a negative side length. A negative distance doesn't really make sense when drawing a triangle. Okay? The negatives that are there are telling us what quadrant it's in. And some people like to label this 2 here with a negative just to say, well, you went -2 to the left instead of 2 to the right. But that distance on that leg of that triangle is still a distance of 2. So that's why we use a positive value for our reference angle. Of course, it could have also, we would have this exact same right angle triangle with the same reference angle with 2 and 3 here in quadrant 3. Because it could have also been for cos to be negative in quadrant 3 as well. Then once you've found your reference angle, you can say what both of those angles are. And again, I'm going to solve this first from 0 to 2 pi. So from 0 to 2 pi, I'm going to store my answer of 0.841 as x into my calculator. And in quadrant 2, it's going to be pi minus my reference angle. And this says write it to the nearest hundredth. So it comes out to 2.30. And in quadrant 3, well, that would be pi plus my reference angle, which is 3.98. Again, these are answers from 0 to 2 pi. After solving it from 0 to 2 pi, I sort of get an idea of the points that I have. Now I'm going to look at the domain that's given. The domain that's given says look at x between -pi/2 to 3 pi/2. Okay? I like to break it up by my negative values and my positive values when I have a domain that starts in the negatives and goes into the positives. Okay? Does it make sense here that my negative values go from 0 to -pi/2 and my positive values go from 0 to 3 pi/2? So the only negative values I'm looking for are these ones. Do I ever hit my terminal arm, my angle, when I look in quadrant 4? No. Right? That 0 to pi/2 doesn't hit that. My positive angles are going from here all the way to here. Did I hit my terminal arm along that way? Yes. So that's why this answer of 2.30 is right. And if I went all the way to 3 pi over 2, did I hit that arm? Yes, that's this angle, which means this one is also right. It's just coincidence that our answers from 0 to 2 pi were also the answers in the domain that was given. But we had to think about that to make sure that we checked that that was right. Now that we've got our answers that are also in the domain that it's asked for, it also asked us to write the general solution. Again, our general solution, you solve first between 0 and 2 pi, which we did already. You take your answers, which were 2.30 and 3.98. Add 2k pi to each of those, and you have your general solution. All your general solution is saying is I have one angle, and then the plus 2k pi keeps going around one full time around the circle, and that will list every single coterminal angle with that original angle. All right, for part B. Part B says solve between negative 180 and 180, so we're thinking in degrees here. And so again, I'm going to solve once around the circle in the positive direction from 0 to 360. I have a cosecant, so this one's already a little bit different than what it would have been in grade 10. But what you can do with cosecant is you can get it by itself, just like we got sine and cos by itself in our other equations, by dividing both sides by root 2. And if cosecant is equal to negative root 5 over root 2, cosecant is the reciprocal of sine, then you know that sine is equal to root 2 over negative 5. Notice the angle isn't changing. When we change from cosecant to sine, when we work with our reciprocals, our angles don't change. But what does change is our ratio. Right? Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite, right? But when they teach you SOHCAHTOA, they don't teach you cho-cha-tau. No, cho-cha-chow. Something like that. That's what it would be if we used all of our reciprocal functions. SOHCAHTOA, for whatever reason, you've heard that so much, maybe, that you remember sine opposite over hypotenuse. But cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. Cho-cha-chow. Cho-cha-chow. It almost sounds, the end of it, almost Portuguese. So maybe they use this in Portugal instead of SOHCAHTOA. I'm not sure. Yeah, don't memorize that. So now that we have sine, again, is this a calculator question? Yes, because root 2 over negative 5 isn't on our pi plate. We always find our reference angle first. Our reference angle is always with the positive values. So we go to our calculator. We go sine inverse of the square root of 2 divided by 5. And we get a reference angle of 0.286, 287 if rounded. I'm going to store that value into my calculator because if sine is negative, that means my angles are in quadrant 3 and quadrant 4. So if you like drawing out the triangles, you can do that. Once you've done a bunch of these, you can just sort of imagine those triangles in your head. And I can say if it's in quadrant 3 and my reference angle is 0.287, I can go pi plus my reference angle, and my angle in quadrant 3 will be 3.42. Now, at this point, I'm working in radians. Was this question in radians? No. So at this point, I'm going to go back and say, oh, I needed to do this in degrees because my question's in degrees. So I go to my mode button. I go back. I change things into degrees. So on your exam, you're often going to be flip-flopping from degrees to radians and radians to degrees, depending on the question. So I'm going to go back and do sine inverse of root 2 over 5 again still positive. And now I find out that my reference angle was 16.4 degrees. So now in quadrant, I'm going to store that value as x. In quadrant 3, it'll be 180 plus my reference angle. Checking it says to the nearest degree. So rounding that to the nearest degree will be 196 degrees. And in quadrant 4, it'll be 360 minus my reference angle. And rounding to the nearest degree will be 344 degrees. This, again, is solving once around in the positive direction. That's from 0 to 360 degrees. Once you've done that initial thing, you're always going to go back and check, what was my actual domain? My actual domain was from negative 180 to 180. So had you drawn out your triangles, you have one triangle here in quadrant 3. You have another triangle here in quadrant 4. If we are looking from negative 180 to 180, our negative values we're looking at are from 0 to negative 180. Our positive values are from 0 to positive 180 degrees. This is where we'll check in the positive values. This is where we'll check for our negative angles. Which way do we hit those terminal arms? With the positive ones or the negative ones, or both? Just with the negative ones. So in fact, both of these answers aren't going to be part of our final answer, because our final answer is going to be this one right here. So if our reference angle was 16 degrees, that angle in the negative direction would be negative 16 degrees. And this one right here, and again, when I'm dealing with negative directions, I like to think positive numbers first and change my answer to negative in the end. So can you see for that one in quadrant 3? You could think going 180 minus your reference angle of 16 degrees and get 164 degrees, but since we're going in the negative direction, that'll be negative. So we've solved it between negative 180 and 180. Now our general solution, again with our general solution, we take our answers from 0 to 360, which happen to be 196 degrees and 344 degrees. And since we're dealing in degrees, we add 360 times k. Questions 6 and 7 for practice here.